How to find the value of output that maximizes total revenue and corresponding maximum total revenue? The question is maximize total revenue, that is total revenue function is equal to 400q minus 8q square. Q is our output. We need to find the maximum total revenue, that means the output level and the total revenue. Okay, maximum obviously. So we are being given the total revenue function is TR is equal to 400q minus 8q square. Okay, so we want to maximize it. Graphically, it simply means, let us say we have output on the horizontal axis, total revenue on the vertical axis. So since it is a quadratic function, it will look like this. Okay, this is our total revenue function. We need to find out the value of total revenue, that means the value of output which maximizes total revenue. Okay, so the condition is simple. Okay, let me write it here. Total revenue will be maximum when marginal revenue is equal to 0. Okay, and what is marginal revenue? Marginal revenue is simply the derivative of total revenue function with respect to output, and when we set it equal to 0. Okay, so it will maximize our output level, or rather it will maximize our total revenue. So taking derivative of this function with respect to q, so derivative of q is 1, so we are left with 400 minus derivative of q square is 2q, so 2 into 8 is 16. Q should be equal to 0, which implies 16 q is equal to 400, or q is equal to 400 divided by 16. So q will be equal to, so we have 4 4s are 16, 4 1s are 4, so this comes out to be 100 upon 4, which is 25. That means the value of output that maximizes total revenue is 25. But to make sure that we are at maximum, we need to check the second order condition. That means second order condition requires that this is our first order condition. Okay, so this is our first order condition. First order condition is simply we take the derivative of total revenue function with respect to output and set it equal to 0. To make sure that we are at maximum, we take second derivative of total revenue function. So this is our marginal revenue. Okay, that means d square tr upon dq square. Okay, let us see. Since it is the first derivative of a constant is 0, derivative of q is 1, so we are left with minus 16. Since the value of second derivative is negative, okay, that means obviously this point will be maximum. Okay, so second derivative is used to check whether we are at maximum or minimum. First derivative simply tells us the point where slope is equal to 0. Okay, let us say if we have this kind of function, okay, here the slope is 0, here the slope is 0, so this gives us the first derivative. Rather, the first derivative tells us the slope is equal to 0. But to make sure that we are at maximum or minimum, we need to check the second derivative. If second derivative comes out to be negative, that means we are at maximum. If the value of second derivative comes out to be positive, that means we are at minimum. Okay, here the second derivative is obviously negative, that means we are at maximum. Okay, so output level that maximizes total revenue is 25. Now corresponding total revenue, maximum total revenue will be, simply plug the value of q is equal to 25 into revenue function, that is 400 into 25 minus 8 into 25 square. Okay, when you solve this, it will give you the maximum total revenue. Okay, I hope I make myself clear. Thank you.